One of the most difficult to be understood concept in Leaving Cert is called Bohr's theory in chemistry. Bohr's theory states that the energy of electron in any energy level is fixed or quantized. So this word actually comes from quantum physics. And quantized means that the numbers are discrete to each other. In other words, the numbers are separated. For example, in mathematics, generally speaking, we'll think about there are infinite numbers between number 1 and number 2. For example, you can think about 1 and there's 1.1, there's 1.2, there's 1.3, there's also 1.1111, 1.1112, and so on. There are infinite numbers between number 1 and number 2. However, in the quantized concept, we only think about there's number 1 and number 2, which means there's nothing in between. So this concept is applied to Bohr's theory. Now, Bohr's theory states that the energy of electron in any energy level. Now, this means something that's outside of the nucleus of the atom, and the electron can be on these energy levels. At this stage, you can treat an energy level as an orbit of the electrons in an atom. Now, in real case, we all know that energy level is made up of energy sublevels, and each energy sublevel can have one or more orbitals. We're going to explore this idea further in the future lessons, but today you can treat energy level as a fixed path that an electron can have orbiting the nucleus of the atom. So for example, this is the positive nucleus of the atom. So the electron can be on an orbital like this. So in Bohr's theory, we call this orbit, where there's only fixed energy on these orbits. Now, and electrons are going through these orbits with the center of the atom. So it's kind of like a mini solar system where you treat the sun as the nucleus and the planet as the electron. So most importantly, if that concept ever comes to your leaving cert, for example, a question will be asking you, briefly describe Bohr's theory. What you're going to involve in your answer is something like this. So you are going to draw two energy levels. Now the first one is called n equals to 1 energy level. The second one is called n equals to 2 energy level. Remember that we said the energy of electron in any energy level is quantized. So we suppose that there's nothing in between. So there's no energy level 1.5. It's just empty in between. If there's one electron in this model, the electron will stay at an energy level of n equals to 1. And the reason behind it is because this is something called ground state, which is the most stable electron configuration that one atom can have. So in other words, nature is lazy. For example, if you have two options, you can either watching this video by sitting down there, or you can watching this video while running a marathon? Which way would you prefer? Now, most of people would say that they prefer sitting down and watch the video. And the reason why you say that is because this is a relatively stable way for yourself to learn. So the same happens to nature. Now, in this case, if there are two energy levels available, the electron tends to occupy the energy level with the lowest available energy. In this case, n equals to 1 has the lowest available energy. So this is something we call the ground state of this electron. However, if there is a form of energy come from outside of the atom, say, for example, it can be a beam of light, it can be heat energy, internal energy, or something else. If there is energy coming from outside of the atom, then the electron will jump from n equals to 1 to n equals to 2, given that there is a sufficient energy present. So the jumping process may look like this. Say this is an electron. Now, the electron can jump from here to here because of the energy. So you can treat this energy as, for example, you're just lying on your bed, playing with your mobile phone, and your mom suddenly pop in, telling you, look, it's time to go to study. Then what you're supposed to do? Uh, I believe most of you would just listen to your mother, right? So you will stop looking at your phone and go to study. Your mom's voice is like the external energy here. So if that energy is strong enough, then that can make the electron to jump from n equals to 1 to n equals to 2. However, when the electron is at n equals to 2 energy level, which is something we call excited state, the electron itself will become unstable. Think about it this way. So your mom tells you to go study, and you are studying right now. But would you ever study for like 14 hours a day? Of course not. And the reason behind it is study is, to most of people, a very hard thing to do because you got to concentrate, you got to think. Right, it's definitely harder than lying down there and playing your mobile phone. So you tend to be unstable in a higher energy state because study consumes a lot of energy of yourself, right? So it kind of becomes unstable and saying that, no, I don't really want to keep a state of study. I would like to lying down, take a rest, playing my mobile phone. The electron would think the same way, kind of, look, this is a simplified version, right? So the electron will kind of think the same way, so it's kind of unstable on n equals to 2 energy level. Thus, the electron tends to go back to n equals to 1 energy level while release a beam of light. So you may argue that this is a photon emitted from this model. But anyways, this video only focuses on leaving cert, so we don't explore this idea too much. And this is basically what we call Bohr's theory. Now, electrons generally stay at ground state, but if there's any energy coming and the energy is strong enough, then the electron can jump from the ground state to an excited state like this. However, due to the excited state is not stable, the electron will fall back to the ground state will emit a beam of light to outside. So the light emitted, or in other words, energy required to finish this process is this formula here. So this is the energy required, and that represents the energy of n equals to 2, energy level. And that is energy of n equals to 1 energy level. And H is Planck's constant. Planck is also known as the father of quantum physics. And F here refers to the frequency of light emitted. Now do remember, light with different frequency will result in different colors. For example, you see something red color, like that, is because the frequency of light emitted by these letters is within the visible range, and it has a specific frequency or a very small narrow of range of frequency that shows a red color. And the same works for blue color. So the reason why you see this as a blue color is because it has some certain frequency of this type of light. And that is Bohr's theory. So in your Leaving Cert, the question would probably be state Bohr's theory or use Bohr's theory to explain something. Then whenever a question like that pop up, you should always consider to write down everything here on the screen. So firstly, you involve a simple statement. The energy of electron in any energy level is fixed, or we call it quantized. You can choose either word. And secondly, you are going to draw a diagram like this and telling people that the electron can jump from the ground state to the excited state, and it can also go back from excited state to ground state because excited state is not stable. In the process of the jump back of the electron, a beam of light will be released, and the frequency of that beam of light is determined by this formula. So energy difference is Planck's constant times the frequency of light emitted. And that also explains why different metals will give different colors in the flame test. And that is probably the first experiment you ever do in your Leaving Cert Chemistry course. And the reason behind it is because different metals have different electron configurations. So this process for every single element is unique. Thus, different metals will give off different lights in their flame tests.